Hello everybody, and welcome to the second video on tables. In this video we simply continue the thread that we began last time when we introduced two-dimensional vectors or tables. In particular, in this video I will show you how to format the way that these things are printed to the screen. So if you remember last time, the columns didn't really line up well. I will show you how to line up the columns of the table in a pleasing manner. I will then show you how to let the user give you a table. So last time I inputted all the stuff myself in the code, but of course sometimes you might want to let a user give you a table or a matrix. And then I will close with 4 examples of using tables. I will show you how to make the transpose of a table. If you don't know what that means, that is fine. I will show you. I will show you how to print the diagonal of a table to the screen. I will then show you how you can reverse all of the rows, and I will close by showing you how to swap 2 rows of a table. So I should say up front that this video will be on the longer side. Essentially, I have too much material for a single video, but not nearly enough for 2 videos. And these 4 examples here are what is going to take the most time. So if you want to, you don't have to watch all 4 of these examples. If you feel like you know how to swap 2 rows of a table, then I suppose you don't need to watch me do that for you. But these 4 examples are in this video for your reference, and I will put the code for all 4 of these examples on Moodle so that you can play with them yourself if you want to. So in any case, the video is longer than normal, mainly because I'm just throwing in hopefully enough examples to get you comfortable with these tables. So first, let me show you how to line up the columns in an aesthetically pleasing way. You just need to do 2 things. First, you have to include the library io-manip. So this is short for input-output manipulation. And then to actually make the columns line up, you use this command setWidth. So W here stands for width. And then you tell it how wide you want the columns to be. So the smaller this n value is, the narrower your columns will be. The bigger this n value is, the wider your columns will be. So let me just show you that example from last time. Here it is, it's still up. Remember that the columns didn't line up very well. So if you actually want to make this 3 appear over the 13, 23, 33, etc., what you will do is include io-manip, and then right here where you're actually telling things to print, you tell it to set a width. And again, the smaller this number, the narrower the columns will be. So you don't want to make it too small, but you also don't want to make it too big or your table will be too spread out. So let me just run this and show you what it looks like now. Okay, now the columns are lined up in a nice way. And if I change that 4 to a 3, it will be a little narrower. So you can just mess with that number until you arrive at the exact width that you want. But this is how you can make tables print nicely. It's very simple. Just io-manip up here. Just throw that in with all the other stuff we have here. And set width right before you actually print the entry and separate with less than less than. Okay, so next, how would you get a table from a user? Because in the previous video, I created all of the tables myself. I declared them, I filled them in. This nested for loop structure here fills it in. And then, of course, I printed them. But if you want the user to give you a table, what you have to do is let the user tell you a number of rows, a number of columns, and then the user has to be able to fill that in themselves. So that's not such a big deal because essentially all you have to do right here, okay, this was the code that actually filled in that table. Just let the user give that to you with a cin statement. So you are not going to come up with a formula yourself. You are just going to write cin list ij and let the user give that to you. Okay, so let's just create some variables for the rows and columns. Let's ask the user how many rows and get that from them. how many columns and get that from them. And now we have to create a vector with that many rows and columns. So m rows and n columns. And we already have used the name list, so let's just call this something else, user list or something. Okay, so let me just copy and paste this for loop structure here to fill in the table. So now I don't know that I have 10 rows, I have m rows, so I will go up to m on I. Same thing for j, I will have n columns, so I start at column 0 and go up to n minus 1. And now here, instead of filling it in, I will just cn that entry. Although I should probably tell the user where they are. So entry at position I, comma, j, just to let them see where they are. So this will now grab a table from the user. The user can just go entry by entry and put those entries inside of that table. And so let me just, here, instead of printing that original list, let's now print our user list just to make sure that things worked out. Yeah, okay. So let's now run this. Let's do something small so we don't kill a bunch of time, but I'm going to do a 2 by 3. So at position 0, 0, I want a 1, and then a -5, and then a 3. And then, 1, 0, a new row. I'll do 5, 7, 2. Whoops. Oh, okay, you see, I mixed up my names here. User list, right, was the name of my list. Let's just try this again. 2, 3, 1, 5, 6, 4, -6, 3, 2, and there you go. 1, 6, 4, -6, 3, 2. So it was telling me my positions at all times. And so of course you can make this output more nicely, doing something like this. But whatever, this is the idea of how you get something from a user. And now it looks more nice. Okay, so getting a table from a user, you can always mimic this sort of structure. They have to tell you how big the table is, the dimensions of the table, and then you create something of that size, fill it in, and if you ever want to print it, you always just use the exact same nested for loop structure we had before. Now on to the bulk of the video with our first sort of big example here. So this example will show you how to take a table and create its transpose. So if A is a 2D vector, the transpose of A is the table obtained by making every row into a column, and vice versa. So basically rows are now columns and columns are now rows inside of a transpose. So the way that works is like, if you have this table here, 2, 4, 8 was the first row, and the transpose is the first column. 1, 3, 9 was the second row, and the transpose, it's now the second column. So that's what the transpose is. And so notice that if you're thinking about how to create the transpose, the first thing you would notice is that if this is m by n, so this is a 2 by 3, then down here, the dimensions of the table are n by m. So in this case, a 3 by 2. So you've swapped the roles of the number of rows and number of columns. Furthermore, this number 4 right here used to be at position 0, 1, row 0, column 1. Now it's at position 1, 0. Right? So 0, 1 went to 1, 0. 8 used to be at 0, 2. Now 8 is at 2, 0. 9 was at position 1, 2. Now 9 is at position 2, 1, etc. So to create a transpose, all that you have to do is swap the locations, the individual coordinate locations. So what used to be ij is now ji. So let's see what that looks like here. Let me get rid of all of this. oops, no, because I want to be able to, yeah, okay, so I'm going to have the user give me my rows and columns. I'm going to create that table, and then I will now create a new table here. So I will call this transpose. So transpose now, the original table the user gave us had m rows and n columns, so I have to swap those. And now here, I'm going to actually create the transpose. So I don't need cn anymore because I'm going to create it myself. So the question is, what should be inside the transpose at position ij? Well, what should be there is the swapped coordinate entry of the original table. Okay, so just like here, right? What used to be at 2, 3 is now at 3, 2, or whatever. What used to be at 0, 1 is now at 1, 0, etc. So what should be in the transpose at ij, all you got to do is swap those coordinates and pull that entry from the old table, and that will give you the transpose. So here, okay, so here's the user list. So let's just print the user list. And then here we create the transpose. And so here, let me print the transpose. And let me say transpose is. Okay, let's see if this works. So again, the logic here is I first create a table from the user and then print that table to the screen, as we just did a second ago. Then I create a new table that has the dimensions swapped. And then at each position ij, I simply take the swapped position entry from the original table, and then I will print the resulting table to the screen. So let's see how that goes. So let's do this exact thing for my slide here. 2, 4, whoops, sorry, I have to first give it number of rows and columns. So 2 rows, 3 columns. My entries are 2, 4, 8, 1, 3, 9. Oh. Yeah, so you see what happened here. I swapped the roles of m and n, so I have to swap the roles of m and n. Forgot to do that. All right, so here inside the transpose, I now goes up to n because I have n rows, and j goes up to m. That's in contrast to the original matrix, which went to m and n. So when you swap the roles of the dimensions, you have to swap them everywhere. So that's what it's telling me happened there. So 2, 3, 2, 4, 8, 1, 3, 9. And there it gives me the transpose. Okay. So again, doing this sort of thing is challenging, even when you think you have it correct. You know, that error message it was giving me was basically telling me I have no idea what's happening here. And the reason it had no idea was because I had these numbers here wrong, and it didn't know what to do with these out of bounds entries. I was trying to tell it to go to certain places inside of the table that don't exist. Okay. So anyway, these things take getting used to, right? So even I first write something, I think it's correct. It's not always correct. You sometimes have to fiddle with it, like I just did. Okay, so that's how you can create a transpose. Okay, so write a program that does that. We did that. And so I want to put this on Moodle for you. So let me grab this and put it in here. Okay, so that's for our records. And now let's go on to an example of the diagonal. So the diagonal of a table is the set of entries A sub ii. So what does that mean? It just means you're looking at all of the entries where the row number equals the column number. So in this table right here, 2 is at position 0, 0. Row number equals column number. 3 is at position 1, 1. Row number equals column number. Therefore, 2, 3 is the diagonal of this table. So 4, 8, 9, and 1 do not satisfy the property that they are in the same row number as column number. Okay, so for example here, if this is the vector the user gives, the diagonal is just position 0, 0, position 1, 1, position 2, 2, and then we are out of diagonal entries. Oops. Okay, so what we will do is we will write a program that lets the user give us this, and then we're going to pick off the diagonal. So let's come back over here. Let's clear out a bunch of this. Okay, so we still want the user to give us a list. Okay. Once the user has given us a table like this, we then want to pick off the diagonal. Notice the diagonal is a one-dimensional line of numbers. So in this picture here, I have still written them diagonally, but it's simply the list 1, 4, 3. So in other words, the diagonal is just a one-dimensional vector. So what I'm going to do back here is I'm going to create a one-dimensional vector called diagonal, and I will just pick off these entries here. So the issue with the diagonal, though, is that you don't know immediately how many entries are on it. So notice in this case, this is a 3 by 4 table. So the diagonal number is 3, right? So you go 1, 2, 3 entries. What if the table were like 4 by 3? What would happen there? In a 4 by 3 table, you also only have 3 entries down the diagonal. So you just take this column and put it, this last column, put it down here. You still just have 1, 4, 3. So the number of entries inside the diagonal is the smaller of m and n. So if you have a 3 by 4 table, there will be 3 entries in the diagonal. If you have an 8 by 3 table, there are going to be 3 entries in the diagonal. So the first thing we have to do before we create a diagonal is just figure out which is bigger, m or n. So let's just write a little command like this. So int diagonal size if m is less than or equal to n, so m is smaller, we want diagonal size to be m, the smaller of the dimensions. Otherwise, we want diagonal, oops, I spelled diagonal wrong. We want diagonal size to be the other number. Okay, so again, what's happening here is that in an m by n table, whichever of those dimensions is smaller, that will tell you the number of entries in the diagonal. So you have to figure out what the smaller dimension is and make your new list, your diagonal list, have that size. So once I know the size of my diagonal, I can just create a one-dimensional list. So vector int, I'll just call it diagonal, and I want it to have this size, diagonal size. So for this table right here, this is 3 by 4. So 3 is smaller than 4. So diagonal size will be 3. And then I create a list of size 3. Now I need to fill this list in. So for int I equals 0, I less than diagonal size, I plus plus, I need to just go through and fill the diagonal entries in. So the question is, what is sitting at, diagonal underscore size. So what is sitting at entry I inside of my diagonal list? Well, what's sitting at position 0, back up here, right? What's at position 0 of the diagonal is the entry at position 0, 0 in the original table. And what's sitting at position 1 inside the diagonal is the entry at position 1, 1 in the original table. And what's sitting at position 2 inside the diagonal is the entry at position 2, 2 in the original table. So you can see the pattern here. If you want the entry at position I inside of the diagonal, you go back to your, I forget what it's called now, user list. So user list was the original table. Just pick off what's at position I. So what's happening is, inside the original table at position 0, 0, that becomes the first entry in diagonal. Then entry 1, 1 becomes the next entry, 2, 2 the next entry, 3, 3 the next entry, and so on. all the way until you're done. And so now let's just print the diagonal to the screen. So cout diagonal is, and we'll just use our one-dimensional vector printing for loop, I less than, diagonal size, I plus plus, and we'll just print diagonal I. Okay, so let's run this and see if this does what we want. I'm going to give it this table here from the slide. So 3 rows, 4 columns, 1, 6, 4, 3, 2, 4, 4, 8, 5, 4, 3, 2. And it tells me the diagonal is 1, 4, 3. So it picked off 1, 4, 3. Okay, good. So it worked. It always feels nice when it works. So just to summarize here, right, this code up top is what we had already, getting something from the user and printing that original table to the screen. What's new is, starting right here, we have to think about how many entries are in the diagonal. We get that from the smaller of the 2 dimensions of the original table. So we have to pick off the smaller of the 2 dimensions. We create something of that size now, diagonal size, and then the entry inside of the diagonal list at position I is simply the corresponding entry along the diagonal in the original table, the entry at position II in the original table, and then we create this diagonal, then we print the diagonal to the screen to verify that it worked. Okay, so we are now done with this example. I should mention that if you want to think about how to get your diagonal to print like this, so that you're thinking of the diagonal as still living inside of the original table, you just don't see the entries anymore, that is a fun exercise that you can do. You have the tools to do, but I will leave it to you to figure that out if you want. Okay, so in other words, I printed the diagonal in a line like this, right? But maybe you could think about how to print it in a diagonal line like this, as if it were still sitting inside the table. And so just for our records, so I can do this for you on Moodle, I'll put that in there also. And now let's move on. So the next example is, how do you take a table and reverse all of the rows? So in other words, if the user gives you this, how do you give them back this? Where the first row is now written in reverse, the second row is written in reverse, and same for the last row. What would that look like? So let me come back here and let me clear out everything except for the user giving me stuff. Okay, so this code up here is still just the user is going to give me something. So let's think about this. How could you reverse, maybe not all the rows at once, but suppose I said, if the user gives me this, how do you simply reverse that top row? Forget about the other 2 rows. I think you would probably say to yourself, well, we already have this reverse command, right? This command that reverses a list, a one-dimensional list. And oh, look, this top row is a one-dimensional list, isn't it? So maybe I can just use the reverse command on this row. Oh, but then I'm supposed to do it on all of the rows, so then just keep going. Okay, so in other words, each row is simply a one-dimensional vector in and of itself. You have a one-dimensional vector there, there, there. So it seems to me that what you can do is just go row by row, which is just vector by vector, and reverse each of those until you're done. So let's just see if that works. So what would that look like? I have to go row by row. So I have to start at row 0. I have to go up to row m minus 1 because there are m rows, and I'll go row by row. So what I want to do is use that reverse command, reverse. And what do I want to reverse? Well, at a given row, I'm at position I, so user list I. And then I just want to do begin user list I dot end. So what is this trying to do? This is saying, look, when I'm at position 0, I just want to look at user list 0. What is that? That is just the list at row 0. And then when I is 1, I'm looking at the row at row 1. And when I is 2, I'm looking at row 2, etc. I would just keep going through all of the rows. And if this right here means anything, it should just mean take the list at row I. So let's just see what this does. Okay, so I'm going to give my table to the program. It will then print the original table to me, and then hopefully it will present things with the rows reversed. Let's just see if it does that. Okay, so let's just give it this table, 3 by 4, 1, 6, 4, 3, 2, 4, 4, 8, 5, 4, 3, 2. Oh, good, it worked. Okay. And so this right here, if you're not used to this, this is pretty confusing as to what this for loop is doing. So let me just talk it out one more time. I here is keeping track of the list at row I. So in other words, each row is itself a list, right? 1643 is a list. It's a one-dimensional vector. So this bracket I, what you're doing is you're picking off the list at row I. So if I were to do this, the computer wouldn't know what to do with that. Okay, so it's yelling at me already because this is now just a single number at position ij. Right? That's just like if I is 0 and j is 1 or something, right? You're just talking about this 6 right here. It doesn't make any sense to sort a 6, the number 6. But I'm not talking about a specific position inside the table. I'm talking about just row I. And the way you can access that is just by doing a single bracket telling it the list you're interested in. I'm interested in the first list. So again, the way the computer sees this table, it sees that table as a list of lists. So it's the list of lists where the first list is that, the second list is that, third list is that, right? So if you just don't give it a second coordinate here, if you leave this bracket j off, you're telling the computer, whatever I is, please access for me that list at row I. Okay, so again, this takes some getting used to, but it does work. It does take each of the individual lists and reverses them. So let me record this for our records also. And let me now move on to the last example. Yeah, so I guess this slide I put all my thought process. Anyway, you reverse the entries of a one-dimensional vector as we did already, right? Using the reverse command. Okay, let's close with probably the hardest example here. Let's let a user enter a table and they're going to choose 2 different row numbers. And what should happen is the program should swap those 2 rows. So if the user enters this table, and furthermore they say, oh, row 1 and row 2, the program should create this table and print it. Okay, so this is quite a bit of a challenge, especially if you're not used to these things. So here's the approach I am going to take. I know that if the user gives me 1 and 2 inside of this table, they want this row swapped with this row. So the strategy I'm going to use is I'm going to create a copy of this row and a copy of this second row, and then I would just overwrite the original rows using my copy. So in other words, I'm going to create a copy of 2448 and then a copy of 5432, and then I'm going to overwrite this row with my copy of 2448. And then I'm going to overwrite this row with my copy of 5432. So 2 separate copies, and then I can overwrite whatever I feel like. Okay, so let me clear out all the stuff from last time. Okay, so here I've just given a table. So now we have to ask the user, so int I, j, cout, give me 2 row numbers, and I will swap. And for the sake of time, you should make sure in like a real program, right? You would need to make sure that I and j are in bounds. So if the table is 3 by 4, the user can't choose a 17 for I or something, right? And I suppose you would also want to ensure that I and j are different, so you're actually swapping things. So in a real beefed up program that you would write in class, I would force you to make all this happen. But for the sake of time, let me just tell you that you all know how to do that. You just have these little check validation loops in here that ensure that I and j do what you want. So I will skip that step, and I will just show you how to swap the two rows. Okay, so to make a copy of row I, notice that row I, whatever it is, if you're talking about row 1, that is a list of size n, where n is the number of columns. Okay, so let me say that again. If you want to make a copy of row 1, you're going to have to create a list of size 4. Right, 4 entries, but 4 is also the number of columns. So back up here, how many columns? N. Okay, so if you want to make a copy of row 1 or whatever, you are going to have to create an integer vector. Let me just call it row I, and its size will be the number of columns. And same thing for the second one, row j. The size will be the number of columns. So now I need to create these two rows. So right now these are empty. I need to make it so that row I really does correspond to like this row, if that's what the user chose. And row j really does correspond to this row, this 5432, if that's what the user chose. So first, let me set up row I. So my for loop here will run up to the size, as always, position by position. And I want to fill in this row I. I probably should have used a different letter besides I, but that's all right. So I need to tell it what happens at row I at a given spot. Well, what happens to row I at a given spot is that, and actually, yeah, let's make this a different letter so it's not so confusing. Well, you can choose whatever letter you want. I don't like my subscripting the same letter as my position. So K is keeping track of my position inside of row I. What do I want my position to be? Well, at the beginning, let's say the user gives me this, right? I want row IK to be this 2. But that 2 is my original guy. I have to tell it the row number I'm in. And remember, I is keeping track of row number. And then what will K do? K will start at 0, at column 0, and then go to column 1, column 2, column 3. Okay, so let's process what this is saying. This is most likely quite confusing, okay? So let's give some real live numbers here. Let's say we're dealing with this table, right here, and the user gave me row 1 and row 2. So this first vector here, row I, is really row 1. I want to make a copy of this row 1. So how would I do that? Well, I would start by letting row 1 at position 0 be 2, row 1 at position 1 be 4, row 1 at position 2 also be 4, row 1 at position 3 be 8. So notice that as I'm moving along, I'm moving column by column as I move my mouse. So what that suggests is you should create a number here that's keeping track of column position, and as you go, that guy will fill in, as you go column by column, that guy will fill in this row I. And same thing for row J, you just now, row J, row J. So let's just see if this is doing what I'm claiming it's doing. The entries of row I copy R. So we're going to take this out later, but let's just see if I 0 less than, what's my size in I plus plus. So let's print row I at position I. So let's see if that does what I want. So cout, oops, supposed to be a semicolon. So in other words, I'm just going to check to make sure that this first for loop is doing what I'm claiming it's doing. So I'm going to give the program my table, right? So that's what all this code up here is going to do. And then the program is supposed to create copies of row 1 and row 2 because those are the row numbers I'm going to give. And we'll see if it makes a copy of row 1. So 3 by 4, 1, 6, 4, 3, 2, 4, 4, 8, 5, 4, 3, 2. Give me 2 row numbers and I will swap. Row 1, row 2. The entries of copy of row I are, oh look, so it did pick off this row for me. So this for loop up here must have been doing what I claimed it was doing, just going column by column and copying the number it sees there and putting that into my row I copy. So if that one's working, the second one should be working also. Okay, so let's take this out. Now that you've made your copies, so let me just go back here and make this bigger. If you want to swap row 1 and row 2, you can just make an individual copy of each row, as I've done, and like once I've made this copy, I can just put it right here. I can overwrite all of these entries with my copy from right here. And same thing with this middle row. If I want this 5, 4, 3, 2 to be in my middle row now, I can just put these entries, just overwrite them over this middle row. So what would that look like? Well, I just need a for loop that, I guess 2 for loops. The first for loop will take the first row and copy it onto the second row, and then we'll just create another for loop to do the opposite procedure. So I less than n, I plus plus. So now back in the original table list. And sorry, we should use different letters here so it's less confusing. I'm going to go column by column and copy. So the user gave me the first row. What I want inside the first row is now my second row copy overwriting. So that's what that looks like. So the old position at position IK, so row I, and then K is just going column by column. What I want you to do, please, is put in there what's in row J at position K. So I will grant you this looks highly confusing. And again, you have to get really used to this. But what's happening is all you're doing is taking your row J copy and just putting it over row I in the original table. And then we can do the same thing for the opposite. So now I want row J to now be row I. So let's now, okay, take my printing and see what happens. So let's see out. Here are those 2 rows swapped. Let's see if it works. Oh. So, oops. 3 by 4, 1, 6, 4, 3, 2, 4, 4, 8, 5, 4, 3, 2. I'm going to swap rows 1 and 2. Let's see if it does it. Ah, nice. Okay. So it did it. Let's just see if that was a fluke. So 1, 6, 4, 3, 2, 4, 4, 8, 5, 4, 3, 2. Let's do the first row and the last row. Yeah, that worked. Okay, nice. So, in conclusion on this example is quite hard, I think, because these sorts of for loops right here, I mean, on one level they look simple because they're just a single line of code, but what's happening there is pretty subtle. And again, like, you just sort of have to read it in English. Like, okay, so I've created this new list called row I. What's in row I at a given spot? Well, it's what was in the old table at that same column number, but at row I. So you are picking off the old row I and just going column by column and creating a new vector, a new one-dimensional list that contains that row. And same thing here, like what am I doing right here? So I'm just I'm filling in the entries of row J, and what am I filling in? Oh, so since this J doesn't change, right, K is what's changing, what I must be doing is taking the old table, going through row J, just entry by entry as I up the column number, and creating this new one-dimensional list. So I probably should have mentioned that earlier, right? In both of these for loops, notice I and J don't change. K is what's changing, right? So your row really is fixed. You're inside of row I this whole time. You're inside of row J this whole time. And same thing here, right? You're inside of row I the whole time. So you really are just inside row I, putting a copy of the row J inside of there. Same thing here, this J doesn't change. So inside of row J, putting a copy of row I over that. And the result will be a swapping of rows. Okay, so at the conclusion here, I hope these 4 examples get you somewhat more comfortable with two-dimensional vectors or tables. But again, there isn't just a ton of value in watching me do this sort of thing. There's some value, of course, but really you won't know if you're comfortable with all this until you do it yourself. So I'm going to put all 4 of these examples on Moodle so that you can tinker with them if you want to. And you may want to think about like where's reversing all the rows. You may want to think about, how do I reverse all the columns? See if you can do that. This example here, I swapped 2 rows. Could I swap 2 columns? Things like this. And you are going to see things like that in class, but just if you want to test your understanding now, those are the sorts of questions you would ask yourself. Like, could I see a path, some sort of like a solution path, whereby I swap 2 columns rather than 2 rows? Can I see in my head an algorithm for reversing all of the columns? What would that look like? So hopefully this has been illuminating. I will see you in class.